Alright, so when we're talking about the Pythagorean theorem, it's first important to understand that we're talking about right triangles. The Pythagorean theorem only applies to right triangles, and one of the most common mistakes I see is when people use the properties of the Pythagorean theorem to apply to a triangle that is not a right triangle. I almost got that. Alright, so here we have a right triangle. I know it's a right triangle because I put the little square in the corner, and I'm going to make the sides little a, little b, and little c. And then usually with triangles, which we're not going to see that here, but we'll name this big A, big B, big C. That's not important for what we're doing, but that's just a common practice where the, oh, I did it right. So the angle opposite the side, little a, is big A, and so on. So then there's some names here that matter. So A and B are both called legs. And again, they're all sides in general with a triangle, but when we're talking about right triangles, we call A and B legs. And these are always, A and B they're always going to be the sides adjacent to the 90-degree angle. Alright, so the sides adjacent to the 90-degree angle, we always label A and B, and they're called the legs of the triangle. C, on the other hand, is called the hypotenuse. The hypotenuse is always opposite the right angle. So opposite means across the triangle from it. Adjacent means beside. So the hypotenuse is always labeled C, little c, and it's always opposite the right angle. Alright, so the hypotenuse is opposite the right angle. Now another thing we've seen, the right angle is going to be the largest angle in a right triangle because the other two have to be acute for it to total to 180 degrees. Because of that, the hypotenuse is always going to be the longest side in a right triangle. Alright, so it's always labeled C, it's called the hypotenuse, it's opposite the right angle, and it also happens to be the longest side of the triangle. The other two, or the two shorter sides, are A and B, and they're called legs. Now we're ready to introduce the Pythagorean theorem. The Pythagorean theorem is that a squared plus b squared equal to c squared, and this uses the a, b, and c as I just described them. So a and b are your legs, or your two shorter sides that are adjacent to the right angle, and c is the hypotenuse that's opposite the right angle. It has to be those sides, those particular sides, or it doesn't work. So for example, let's say I have a right triangle where the sides are 3 inches, 4 inches, and 5 inches. And then when we plug that into the Pythagorean theorem, again, this isn't working a problem. This is showing how the Pythagorean theorem works. So we would have 3 inches squared plus 4 inches squared equal to 5 inches squared. Okay, now I'm not trying to solve an equation here. I'm saying these are equal. Now to show that they're equal, this would be 9 square inches plus 16 square inches, or inches squared, equal to 25 inches squared. And then sure enough, that's 25 inches squared equal to 25 inches squared. And this always works out with right triangles, that if you do that a squared plus b squared equals c squared equation, you're going to get a true statement. Now here, again, I'm not working an example problem. I'm just showing you how the relationship works. Now we're actually going to use all of this to work a problem where how we usually use this is we know 2 of the side lengths and we use it to find the third side length. Alright, so here we have a right triangle. We're being asked to find the value of little c. I always emphasize that because there's a big C too, and we know that its measure is 90 degrees. So we're going to start with the Pythagorean theorem as like a formula template. So a squared plus b squared equal to c squared. Okay, now I know my a and b, and it doesn't matter, the legs have to be a and b, but it doesn't matter which one you make a and which one you make b. So I can make this 12 feet squared plus 9 feet squared, and that's going to equal c squared. I don't know what that is. Okay, well, now 12 feet squared is going to be 144 square feet. 9 is 81 square feet. Still don't know what c is. Now when I add those together, 144 plus 81 is going to give me my 225. Units stay the same, equals c squared. Now, in order to solve for a variable being squared, we need to undo the squaring. So what we're going to have to do is square root both sides of the equation. Before, up to this point, we were just simplifying the left side of the equation, but now we're going to undo what's happening to the c squared by square rooting both sides. Now, for those of you that have some robust algebra skills, you might remember that we need to do plus or minus the square root. But in this case, since we're dealing with side lengths, it's always going to be the positive. So we're only worrying about the positive side length. So this is going to equal 225 square rooted is 15, and feet squared square rooted is just feet. So c is 15 feet. I'll do one more example real quick where we have the hypotenuse and we're looking for one of the legs. The algebra is a little bit different. It's essentially the same use of the Pythagorean theorem, just the algebra to solve is different. Alright, so here we go with this example. We have, it's a little different because they gave us the hypotenuse. And I know this is the hypotenuse because it's opposite the right angle, or across from the right angle. So now I'm going to be plugging that value in for c in my Pythagorean theorem. So again, I write out the Pythagorean theorem kind of as a template. A squared plus b squared equals c squared. And like I just talked about, the 122 inches is going to be my c squared. Now this 120 inches can be my a squared or b squared. Algebraically, it doesn't matter. It's just the legs have to be a and b. The hypotenuse has to be c. So I'm going to make it b. And then that leaves us with our a squared, which I'm going to substitute that in to be an x because they asked us to find x just to keep the lettering consistent. And then we're solving this equation. So we have x squared, I gave myself some fun numbers to square, equals 14,400. And then inches squared, that's going to be 14,884 inches squared. So I just squared both of those and then applied the square to the unit. Now I'm going to get my x squared piece by itself by subtracting the 14,400 inches squared from both sides. When I do that, I'm left with an x squared on the left, which is what I'm trying to do, is get that piece by itself, and the difference here is 484 inches squared. Now to get it down to be an x, we have to square root both sides. So I'm going to square root x squared, and that's going to equal the square root of all that stuff on the right. Square root of x squared is x. 484 square rooted is 22, and inches squared square rooted is just inches. So x is 22 inches. So this is very similar to the previous example, except for this step where we had to get the x squared by itself by subtracting from both sides. Go ahead and give some of these a try and see how you fare.